Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of relations and functions. We are solving the examples of the concept of relations. Now look at this question. This is based on the concept of equivalence relation. We have to check whether it is reflexive, symmetric and transitive. The relation is defined on the set 1, 2, 3 and 4. There are only 4 elements in the set A, and the relation is given in the roster form. So all the ordered pairs are listed here. So you got 1 1, 1 2, 1 3, 2 1, 2 2, 2 3 and 3 3 and 4 1. Well, now first check for reflexive. What do you mean by reflexive? See, when do you say a relation is reflexive? If you have A comma A in the relation for every set, for every element in the set A. Now in the set A you got 1 2 3 4, therefore you must have 1 1, 2 2, 3 3 and 4 4. So do you have 1 1? Yes. And 2 2? Yes. So do you have 3 3? Yes. But do you have 4 4? No, you don't have. So if you are missing 1, then this condition that for every element of A you should have A comma A is not fulfilled. Correct? So that condition is not fulfilled. You must have 4 4 also. If you miss 1, then it is not reflexive. Therefore it is not reflexive. Reflexive is given in option B. That cannot be the answer. Correct? So it is not reflexive. Let's move on. So is it symmetric? Is it symmetric? So for symmetric you have to check for the ordered pairs of the type A comma B, right? So if A comma B is there, then B comma A must be there. Okay, right? So if A comma B belongs to R, that implies B comma A belongs to R. Now you got 1 comma 2. So you got 1 comma 2 and there is 2 comma 1 as well. But you have 1 3. So for 1 3 you don't have 3 1 in this. Do you have 3 1? No, you don't have. Therefore you got 3 1, but you got 1 3, but 3 1 is missing. Therefore it is not symmetric. So symmetric, this option is saying it is symmetric. So that is also not correct. Then let's check for transitive. So for transitive you must have if A comma B belongs to R and B comma C belongs to R, then A comma C also should be an R. The first and the last element make a ordered pair. Okay, now you got 1 2, you got 2 1, then you got 1 1, fine, it is there. So you got 1 2, you got 1 2 and there is 2 3 and you got 1 3 also. You got 1 3, starting with 3 you got 3 3, so 1 3 it's there. Then with 4 you don't have anything. Then yeah, so you got 1 1 and starting with 1 you got 1 3, then the resultant is 1 3 which is there. So basically you avoid checking the ordered pairs of the type A comma A. Don't check for these. Okay, don't check for this. Now you got to check only for the remaining things. Okay, so start with this. You got 1 comma 2 and go for starting with 2. Okay, don't go with this. Avoid it totally, because that will always satisfy. Okay, now if you are taking these two, then the resultant is 1 1 which is present, correct? Then if you are taking 1 3, the only option you have is this, so don't check it, it is transitive. Then if you are starting with 2 1, you check for starting with 1, you don't have anything else other than this, don't check it, it is transitive. Then 2 3, starting with 3, you don't have anything else other than this 3 3, so that is also transitive. Then 4 1, then starting with 1, you got this. Yes, so now let's see, you got 4 1 in the relation, and you got 1 2 as well. Both belong or not? Yes, they belong. You should check for all possible orders, okay, not only in the given order, okay. Now what is the resultant? The resultant is 4 2, but do you have this in the relation? Do you see 4 2 in this? No, you don't see, you don't have it, therefore it is not transitive. See, just one example is enough to say that it is not transitive. So you must check for all possible ordered pairs here, all possible ordered pairs here, okay. So you have 4 1, then starting with 1, you got 1 2, or you can go for 1 3 also, 1 3, then 4 3 is also missing. Just one example is enough to disprove something. To prove, everything must satisfy, okay. If you want to disprove it, just one example is enough. So that's the example we have got, and we are saying it is not transitive. So it is not reflexive, not symmetric, and not transitive. So which option is correct? Neither reflexive nor transitive, correct. So it is not reflexive, it is not transitive, it is not symmetric also, but this is correct, this is correct. It is neither reflexive nor transitive. Well, so if you are going for none of this, then this is correct, no? This statement is correct. They have not mentioned symmetric, but still whatever they are saying here is correct. So this is the right option, this is the right option. Well, now let's go to the second problem. See, you have the relation given in this format. So let me write that relation in the traditional method, the normal method. And how do you write it? In the set builder method, you write like set of all x comma y, that means x is related to y. So x is related to y, that means xy belongs to R. You remember this connection? I told you when I explained the relation. So you can represent either way. So either you can write in this way, or you can represent the relation in this format also. So how do you read it? X is related to y, x comma y belongs to R, x is related to y. Well, so you have two options of writing, so you can select any one of them. So now in the question they have given this, and you must be in a position to convert it in the other format. So what is the equation? What is the equation? X minus y plus root 2, and from where do you select this x and y? From where do you select these x and y? So from the set of real numbers. So let me mention it, x comma y belong to R. So all the real numbers can be taken in the place of x and y, and what else is given? See, this is very important. X minus y plus root 2. So that must satisfy. So is irrational. So this must be irrational. So complete the statement. So if it is irrational, what is irrational? X minus y plus root 2. If it is irrational, then x comma y will belong to R. X is related to y if and only if x minus y plus root 2 is irrational. So that's the connection we have in this relation. How x and y are related? Only if x minus y plus root 2 is irrational, then x and y are related. When 1 and 2 are related, if 1 minus 2 plus root 2 is irrational. Right, okay, so that's the understanding. Well, now you have to check reflexive, symmetric, transitive, reflexive and transitive. So let's start with reflexive. So the first thing, reflexive. See, what do you mean by reflexive? You must have a comma a, or in this case I can write x comma x in the relation. So when this will happen, if and only if x minus y, but in place of y I have got x now, so let me write x here and plus root 2. So what do you get? X minus x cancels, you get root 2, and this is irrational. Correct? Yes. So perfectly irrational, therefore it is reflexive. So it is reflexive. Now second option is saying it is symmetric. So if you are saying B option is correct, what about A then? It is reflexive, no? Then if you are saying it is transitive, what about reflexive? It is reflexive. So exclusively you have reflexive in first option, and that's the only answer. You can decide by now itself, but if you want more clarity on symmetric transitive, I'll explain that too. Now what is symmetric? Symmetric means if A comma B belongs, then B comma A must belong. I'll give an example of 1 comma root 2. Okay, so does it belong? Does it belong? Does it belong? Is it irrational? You check on it. Is it irrational or rational? It is rational. Does it belong? See, 1 minus root 2 plus root 2. This will cancel, you will get 1. This is not irrational. So I'll reverse. See, now understand, root 2 comma 1. It belongs. Why? Because root 2 minus 1 plus root 2. What is it? 2 root 2 minus 1. 2 root 2 is irrational. You subtract 1, that will be irrational itself. Yes. So therefore this belongs. But what about 1 comma root 2? We already saw it. It does not belong. It is not irrational. Why? Because x is 1, y is root 2. So x is 1 minus y is root 2, and this root 2 is there already. So this will cancel. You will get 1. This is not irrational. This is rational. I hope you know the difference between rational and irrational. Okay, root 2, root 3, pi, all those are irrationals. You have non-recurring repeated decimals. Okay, you cannot express irrational in the form of p by q. Rational is the number which you can represent in the form of p by q, where q is not equal to 0, p and q are co-primes. Okay, well, this can be represented by p by q, 1 by 1. You can, but this you cannot, because this is irrational. You don't get perfectly fraction here, you don't get any fractions. Well, let's continue. So what we understood, this is not symmetric. Now what about transitive? Well, look at the transitive. See, we understood it is not symmetric, so let's check the transitive part here. Okay, so you must have two things. That means A comma B belonging to R, and B comma C also must belong to R, and then A comma C must belong to R. Now if you are able to give two ordered pairs here which belong to R, but A comma C does not belong, A comma C does not belong, then you can prove that the given relation is not transitive. You are giving a counter example here. You are giving such an example which does not hold for two given ordered pairs. Therefore you can say in general that relation is not transitive. To disprove something, one example is sufficient. Now I'll try to give an example of that type. Say first you take root 2 comma 2 which belongs to R. What does that mean? Root 2 comma 2. See, you got root 2 minus 2 plus root 2, that is 2 root 2 minus 2, which is irrational. And then you take 2 comma 2 root 2, that also belongs to R. Why? Because now x is 2, y is 2 root 2 and then root 2. See, what is it? 2 minus root 2, minus 2 root 2 plus root 2 is minus root 2. This is also irrational because you have root 2 there. Correct. Next, what about the first and the last element? So if you take root 2 comma 2 root 2, then what will happen? See, this is root 2 minus 2 root 2 plus root 2. Root 2 plus root 2 is 2 root 2. 2 root 2 minus 2 root 2 is 0. This is not rational. This is not irrational. It is rational number. You can write 0 by 1, 0 by 2. You can write p by q. No problem. Okay, you can write. So this does not belong. So a comma b belongs, b comma c belongs, but a comma c does not belong. That means it is not transitive. This is not transitive. Therefore, I already told you that the option is reflexive. So because it is not transitive. If it was transitive, then option D would be the right option. So option A is the correct answer. Alright, so let's move on to the third question. So third question, if a relation R on the set, I will give a name to that set. I will write A, and A is 1, 2 and 3, and the relation is very simple. You got only 1 comma 2 in that, just one ordered pair. Then is it reflexive, transitive, symmetric, equivalence? Let's check. So is it reflexive? What do you mean by reflexive? To become reflexive, you must have all the ordered pairs of the type A comma A, correct, in the relation for every element of A. Now for every element of A, for 1 you must have 1 comma 1, for 2 you must have 2 comma 2, for 3 you must have 3 comma 3. None of them are present, therefore it is not reflexive. This is not reflexive. What about symmetric? What about symmetric? Symmetric, if 1 comma 2 is present, then you must have 2 comma 1, but now 2 comma 1 is not there. So that example is sufficient to us to say that it is not symmetric. What about transitive? See, this is interesting. So this is where most of the students are not convinced about the answer. Okay, so please understand this. When do you say it is transitive? If A comma B belongs to R, and the word and is very important. It is not comma or it is not or, it is and. Both must be present. A comma B must belong to the relation, and B comma C also must be there in the relation. Then if both are there, then only A comma C must be there. A comma C must be there. If A comma B is there but B comma C is not there, then you don't have to worry about A comma C. Whether it is there or not, it is transitive itself. Okay. So when you give an example, when you give a counter example, when you give an example to say that it is not transitive, how it should be? It should be like first ordered pair must be there in the relation. Starting with the same B, you must have the second ordered pair, that also must be there in the relation, and A comma C shouldn't be there. Then we can say it is not transitive. Now in this case, are you able to give such an example? If you are not able to disprove, then it is transitive. If you are not able to prove that he has committed a crime, he is innocent. So till you give the evidence that the person has committed a crime, he will be innocent. Okay, so till then you can't say that he is a criminal. You have to provide the evidence, you have to give the example, you have to prove. Okay, so you are not able to give the evidence You are not able to give the evidence here. All right. So you are not able to give the example to say that it is not transitive. Hence it is transitive. Why you are not able to give example? Because you have 1, 2. Agree? Yes. But do you have the second ordered pair starting with 2? Starting with 2, you must have one more, like 2, 3 or something. Then you can speak about 1, 3. Now this itself is not there. How can you say this does not belong? Show me this first, then you can speak about this. Okay, so both must be there, and is very important here. If 1, 2 belongs and 2, 3 or 2, 1 belongs, then we can speak about 1, 1 or 1, 3 here. Now you cannot speak. You cannot give the second ordered pair here. Therefore, this is trivially transitive. This is what you call trivially transitive. You are not able to disprove it. Hence, it is transitive. So this relation is transitive but not equivalence, because it is not reflexive and symmetric. It's not equivalence, it is only transitive. So this is very important example. All right, most people are confused in this. Well, let's move on to the fourth example. Maximum number of equivalence relations on the set A is equal to 1, 2, 3. So you got the set which is very simple, only 3 elements are there. Now you have to tell us the maximum number of equivalence relations, not number of relations. Number of relations is easy to find, that is 2 to the power 3 square, 2 to the power 9. So that is total number of relations. Now you have to tell the equivalence relations possible. So to become equivalence in a relation, you must have 1, 1, 2, 2 and 3, 3. Why? Because it has to be reflexive. So this itself is one relation, and that is equivalence by default. Okay, it is reflexive, all the 3 are there. It is symmetric, 1, 1 and reverse is also 1, 1. Then it is trivially transitive. Okay, you can't give an example to say that it is not transitive. Okay, then that is the first relation, you can say. And what is the second relation? You add some more elements. See, basically this must be there. This is the minimum requirement. All the 3 must be there, then only it will be reflexive. Okay, you are speaking about equivalence now. Then what extra you can have? You can have one more element now just to differentiate them, otherwise it will be same, right? So how many different relations possible and which are equivalence? So I'll add one element. Now when I add this, to make it symmetric, you must have 2, 1 or not? Yes. So if I write in general A, B, then B, A must be there. So how many values for A and B are there? 3 values. So you will get 3 different things. Okay, so what are those 3 different things? The 3 different things are these: 1, 1, 2, 2 and 3, 3. Now instead of 1, 2, you can write 1, 3. Correct? And you can have 3, 1 here. You should have 3, 1. Then R4 so now you can write 1, 2, 1, 3 is over. So you have 2, 3. So then 3, 2 must be there. Correct? So 3, 2 must be there. So this is also equivalence. This is also equivalence. Now the next possibility is you have the universal relation, the full relation. So that will be always equivalence. See, you may think, sir, I can write 2, 1 first. So if I have 2, 1, then I'll write 1, 2. But that is basically same. No, in the set, the order does not matter. You write 1, 2 here or 2, 1 here. It is the same thing. Okay. So instead of 1, 2, if you write 2, 1 within the ordered pair, order must be maintained. But within the set, you need not maintain the order. You can write this 2 comma 1 first and 1 comma 2 later. Same relation, it's not different relation. Okay, so you got 4. Now what is the fifth relation? The fifth relation is you have 1 1, you have 2 2 and 3 3, and then 1 2 and 2 1, and you write 1 3 and 3 1. Okay, so if you stop at this, you may say, okay, I'll write only these two, so I'll get one more R6 where I'll write this and this, and R7 this and this. You may think like that, but let's check. Is it equivalence? You see, you have 1 2, right? Forget 1 2. You have 2 1. So starting with 1, you have 1 3. Do you have 2 3 in this? You don't have 2 3. Therefore, this is not equivalence. You can't just write two things here. Okay, these two things you cannot write and stop. You must write 2 3 to make it transitive. Otherwise, it is not transitive. So when it will become transitive, if you have 2 3 and 3 2, so this is universal relation. All the elements are present here of A cross A, and that is also equivalence. So you got totally 5, and the maximum you have is 5 here. Okay, so that's the right answer. Well, so that's it for today's class. Thank you for watching. Keep watching these classes. You will learn many concepts of relations and functions which are related to CET and JEE. Let's look at the question number 5. Define a relation R on R. What is this R? Set of real numbers as A is related to B if and only if A is greater than or equal to B. So how do you write that relation in the normal terms? Okay, so in the set builder form you can write this way. So that is set of all A comma B where A and B belong to the set of real numbers and A is greater than or equal to B. So that's the way you can write the relation, and you have these options. First, equivalence, so you have to check reflexive, symmetric and transitive. Let's do that first. So for reflexive you have to check for A comma A, correct? So now do you think A comma A belongs to R? When it will belong? If A is greater than or equal to A, correct? So A comma B belongs to R if A is greater than or equal to B. Now we are talking about A comma A to make it reflexive. So that means A must be greater than or equal to A. Is it true? Yes, because you have equal sign. A is equal to A. So it is true. Therefore, it is reflexive, obviously. Then second, is it symmetric? So for symmetric, we must have A comma B which belongs to R, and there must be B comma A as well. If A comma B belongs, then B comma A must also belong. So when do you say A comma B belongs? If A is greater than or equal to B. Now, do you think B will be greater than or equal to A? Need not be. So let's take the example. So what example you can take from the real numbers? You can take any integer. So I'll take 2 comma 1. So we can say that 2 is greater than or equal to 1, but do you think 1 is greater than or equal to 2? No. So it is not. Therefore 1 comma 2 does not belong to R. Therefore it is not symmetric. Therefore it is not symmetric. See, remember, it is reflexive but not symmetric. Let's check with the transitive. Well, the third thing, transitive. When do you say the relation is transitive? If you have A comma B in R and B comma C is also found in R, then you must have A comma C. See, when do you say A comma B belongs to R? If A is greater than or equal to B and B is greater than or equal to C. If B comma C belongs, now what you should have? You should have A is greater than or equal to C. So does it happen? Yes. So you take 3 comma 2 and then 2 comma 1. 3 is greater than 2. 2 is greater than 1, then obviously 3 will be greater than 1, correct? So you can go for any other numbers and it will always satisfy. Therefore A comma C also belongs to R, hence it is transitive, it is reflexive but not symmetric. So it is reflexive and transitive but not symmetric, and that's the right choice. Okay, so not reflexive is given, but it is reflexive. Here they have given it is neither transitive nor reflexive, but both the things happen. Therefore the only choice for us is option B. Well, so that's it for today's class. Thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.